Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. We didn't spend very much time on area because we kind of got to start moving things along. We're going to be moving on to volume today. Our three basic solids: prisms, cylinders, and spheres. Now, I wanted to come up with some way of helping you guys kind of visualize this. So, what I did was I was looking around for different things that might be prisms in my house, and we could have gone with the traditional box or rectangular prism, but I wanted something that was a little bit more dynamic so we could kind of dissect this a little bit. And I wanted to go with something that was a more interesting prism. So I went around and I started searching for prisms, and the one that I found first was actually a pentagonal prism. And it's one you guys are all very familiar with. I guarantee it. It is a milk carton. Now, in order to make this a pentagonal prism, we're going to have to ignore this top part right here. So, notice that we've also got to assume this little indentation isn't here. We're just going to pretend that's one solid face, which is a pentagon. So notice you got your pentagon here, flip it around the other side. We've got our pentagon here, and then we've got all the other sides. This one is a rectangle. 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 And then again, this one right here, this is low-fat milk, is also a rectangle. The reason I bring that up is because a solid is made up of a whole bunch of different shapes. Now, the question that we're going to have to asking ourselves a bunch in this unit for just about every single shape is, where is the base? Now, we are used to this thing sitting like this, and so many times people want to say that is the base. But just like when we were studying triangles and trapezoids back in the polygons unit, the base is not the thing that it's sitting on. The base is the definition, or is determined by definition, not by the way it's sitting, because the base never changes. I could turn it this way and the base is still the same. I turn it this way, the base is still the same. I could turn it any way I want and the base never changes. If you're determining it based on what it's sitting on, then you would say that that's it, but it's not. The reason I brought up all those shapes earlier, rectangle, 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 pentagon, pentagon, a prism is always named after its base. This is a pentagonal prism, therefore its base is the pentagon. This is the base. Also, another way of looking at it, if you look at all the different shapes, the bases are the ones that are not rectangles. So rectangle, 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 not the bases. Pentagon, pentagon, those are the bases. You also know the two bases are always parallel to each other. Okay, so we'll be talking about different well, the height also is the perpendicular distance between the two bases. So I'd measure my height here or here, any of these edges that go between the two bases at a right angle. Okay, so anytime we talk about the base, it's always the thing that's named after, the one that's not a rectangle. But then that brings up the question of, what if they are all rectangles in a rectangular prism? In that case, use anything as the base. I don't care. It will always work. Okay, let's jump into our notes here. Now, we're doing just volumes. We're not going to worry about surface areas right now. So, let's see. First off, lateral faces and lateral edges are all of the non-base faces and all of the edges that connect those together. So lateral faces would be, in this case, we have a hexagonal prism. And so all of our rectangles here, just like I said earlier, those are my lateral faces. The lateral edges are the ones that connect the two bases together, the ones that I called heights earlier. A base edge is going to be one of these along the base. Okay, so any of these 6 on top or any of these 6 on bottom. The altitude or the height, again, just the distance of those lateral edges. Volume of a prism. The volume of a prism is going to be area of the base times the height. Now, back when you were in elementary or middle school, you may have seen something like this. Volume equals length times width times height. And that is absolutely 100% true for a rectangular prism and only a rectangular prism. You see, this length times width right here you were given the area of a rectangle is equal to length times width. So what you're actually doing there is saying that this is the area of the rectangle times the height, which is all that we're doing here. We're using capital B as the area of the base, okay? Capital B is always area of the base. So find the area of the base, which again is that non-rectangular piece, the pentagon for a milk carton, the triangle on a triangular prism. Find the area of that base, then multiply it by the height, the length of a lateral edge, and you have the volume of a prism. Now, a cylinder. I like to refer to a cylinder as a circular prism. You're not going to hear that phrase very often, but it actually works very, very well because all of the properties of a prism also apply to a cylinder if we just think of the circle or the base as being a circle. So here's what I want you to notice here. Volume is pi r squared. Notice that pi r squared is still just the area of a circle. So this is still volume equals area of the base times the height. Okay, so we've got our two formulas. Let's go ahead and jump in and do some examples. Find the volume of the prism. Well, volume equals area of the base times the height. My first step on this is always going to be figuring out what the area of the base is. So I'm going to jump over here on the right in purple and figure out the area of the base. Well, our base here is the triangle. Notice once again, it is not sitting on its base. Either one of these two triangles works. So we're going to use our area formula for a triangle, which is 1/2 times base times height. Now I want to go ahead and point out this little bitty tidbit here. Notice I've got capital B for base and little b for base. There are two bases in this scenario. Context is everything. When we talk about capital B, that is the area of the base, that area that I shaded there in purple on the shape. Little b there is going to be the base of the triangle. In context, it has to be, which the base of the triangle is just this piece right here. So when we go through and solve that, we're going to have area of the base equals 1/2 times the base of the triangle, which is 10, times the height of the triangle, which we get right here is 12. Now we're going to multiply that through. Let's see, 1/2 times 10 is 5, times 12 is 60. Okay, now we're going to jump back in and plug that into the volume formula. Volume equals area of the base, B is 60, times H. Now here's our second little thing we got to point out. Notice we've got two different H's in this. We've got this H and we've got this H. Over here on the left, this is the height of the prism. Over here, this is height of the triangle. Once again, context is everything, because over here, this is all about the triangle, and so therefore the 12 has to be used. The 25 has nothing to do with the triangle. Now, we jump over here on the left, and we're doing the height of the prism. On a prism, the height is the distance between the two bases. In this case is 25. Now, we just multiply that through, 60 times 25, and my volume is 1,500 centimeters cubed, always units cubed on the volume. So, got to keep track of your bases and your heights in context, and I apologize for there being multiple variables with the same name. It's just the way that these things work. All right, now we're going to do the same idea here. Volume of the prism. Volume equals area of the base times the height. Now we need to jump in, same thing we did earlier, and find the area of the base. Well, the trapezoid is going to be the base. It's a trapezoidal prism. I'm going to shade that on the back. And our area formula for a trapezoid, if we remember from last unit, is 1/2 times base 1 plus base 2 times height. And once again, let's make sure we keep track of what our base 1s, base 2s, area of the bases, all that sort of stuff is. All right, now let's talk about our our two bases on a trapezoid. Again, that is the two parallel sides of a trapezoid. So we're going to have the 2 plus 4. Now the height of the trapezoid is the distance between the two bases of the trapezoid, which here is 1.5. Now let's go ahead and type that in. 1/2 times 2 plus 4 times 1.5. The area of my trapezoid is 4.5. Now that we've got that, we're going to jump back over to the volume formula on the left. Volume is area of the base is 4.5 times the height of the prism, which now is the distance between the two trapezoids, which is 6. 4.5 times 6. 27 centimeters cubed. All right, moving on to example 3. Now this guy is a little bit crazy at first. This is what we call an oblique prism. That's just a fancy word for saying that it's slanted over, sort of like the Leaning Tower of Pisa, like something's come in and pushed this guy over. Here's the good news about this. As long as you know the true height, the perpendicular height, you can use the exact same formula. Volume equals area of the base times the height. Now, the height has to be perpendicular. You see, if I had this distance right here, that is not the height because it's not perpendicular. Remember, we would never go in and measure a person's height by putting the tape measure way over here on the ground and measuring it like this. We always measure straight up and down. Okay, so we're going to do the exact same thing we did before, just using this 12 as the height. Area of the base. Now for a rectangle, you can use base times height, you can use length times width, doesn't matter. 10 times 15. Ew. So the area of my base is 150. Now, plug that in for base on the left, or area of the base on the left. Now the height we already talked about, we're going to use this 12. So 150 times 12 is 1800, and our units are feet cubed. Remember, we're doing cubed on everything here, or all of our units for volume. All right, let's jump over to a cylinder. Now, once again, you could use base times height and then jump over here as base is pi r squared, or you could use the shortcut formula pi r squared h. Either one works. Honestly, I prefer to do this one because it's more direct, and so that's what I'm going to do. So I wrote that out, so you can use it if you want to, but I'm not going to. All right, here this is easy because my radius is 1.8 and my height is 1.8. So we're just going to plug those in. Pi times 1.8 squared times 1.8. Pi times 1.8 squared times 1.8. And volume equals 18. It says nearest tenth in the problem, so 18.3 centimeters cubed. All right, moving on. Example 5. Volume equals pi r squared h. Now you'll also notice this is an oblique cylinder. Same property applies as long as I know my true height here. The danger people do on this one is coming in and just putting the 13 in. The 13 is what's called a slant height, and that does not work here. We cannot use that. In this case, we're going to have to solve for h. But if this slant height is 13, then so is that one. So I have got a, well, I drew that too far over. I have got a right triangle right here in which the sides are h, 13, and 5. So I can go through and do Pythagorean theorem to find h. H squared plus 5 squared equals 13 squared. So h squared plus 25 is equal to 169. Subtract 25, h squared equals 144. Then take the square root, h equals 12. Now we're ready to start plugging in. Oh, I also noticed that this 8 is the full diameter. So if the diameter equals 8, then the radius equals 4. All right, now I'm ready to plug in. Volume equals pi times 4 squared times 12. Pi times 4 squared times 12. And once again, the nearest tenth. So that's 603.2 inches cubed. Okay, last shape of the day, volume of a sphere. We're not going to bother with going through where this volume comes from. Incidentally, if you ever do take a calculus class, usually during the second semester of calculus, they'll actually show you where this formula comes from, but we're not going to mess with it right now. So 4/3 times pi times r cubed, where r is just the radius of the sphere. So very simple, straightforward formula. The most difficult part is multiplying by 4 and dividing by 3, but you'll be fine. Okay, here, my radius is 8. Volume equals 4/3 pi r cubed. 4/3 times pi times 8 cubed. Now, watch this in the calculator. 4 divided by 3 times pi, we're using the pi button on all these, times 8 caret 3. Volume equals 2144.7 centimeters cubed. That's just a glorified calculator problem. All you gotta do is type it in. All right, volume of a hemisphere. Now on this one, we're going to find the volume of the sphere and then just divide it by 2. So let's do the volume of the sphere is 4/3 pi r cubed. So volume of the sphere is 4/3 times pi times, now if the diameter is 6, then the radius is 3 cubed. 4/3, 4 divided by 3 times pi times 3 cubed. So the volume of the sphere is 113.097. Now the volume of the hemisphere is just half of that. It's just 113.097 divided by 2. So I'm just going to hit divided by 2 there, and that gives me 56.5 feet cubed. All right, that's it. Relatively simple. Just make sure you're keeping track of your formulas, and notice on every single one of these, I plugged it in before. I wrote down the formula before I plugged it in like this. I wrote down the formula, and then I went down and plugged it in. Very good habit to get into. As it is, it'll be all right. Feel free to ask me questions, shoot me email, get on my office hours, whatever you need to do. And guys, take care of yourselves. Please stay patriotic.